Now let's look at how to solve this problem using classes. First, let's see how to declare and define a new class in C++. Then we will see what are the design considerations one need to think about when creating a new class. And finally, we will see how to overcome some of the challenges that we saw without using classes to create our employee management system. So let's begin by declaration and definition of a class. To declare a new class, you will use the keyword class followed by a name. Since we are creating an employee management system, the name of our class will be employee. Now, within braces, we will provide the body of a class, and then at the end, the semicolon lets the compiler know that the declaration and definition is completed. Now, each class in C++ will hold data members and member variables, data members and member functions. The data members will be used to describe our class object, and the member functions will be used to access and modify these data members. So for example, with our employee class, we have four data members. These are name, position, location, and pay rate. So these data members can be used to describe an employee. And the member functions now will be used to access and modify these data members. So for example, a member function can be get name, which will return the name of an employee. Now the first thing that one needs to think about when creating a new class is to choose which member functions and member variables should be accessible from outside the class, and which member functions and member variables should be hidden from outside the class. Now to do this, you can use access specifiers in C++. There are three access specifiers in C+: public, private, and protected. Public is the least restrictive access specifier, protected is in between, and private is the most restrictive access specifier. So any data member and member function that is declared as private cannot be accessed directly from outside the class. They can be only accessed within the class using some member functions that are public. So for example, here I'm creating four data members which are all private. So the syntax is, first we specify the access specifier name followed by a colon, and then every data member and member function that is declared after that until a new access specifier is provided will have the previous access specifier. So from line 15 to line 18, all the member variables that were declared will have access specifier private. Now since we are declaring a new access specifier in line 20, everything that follows it will have public access. That is, they can be accessed directly from outside the class using an instance or an object of our class. Now each class in C++ will have a few inbuilt member functions. These member functions are provided to us by default by the compiler. So we have a choice of either using the default versions of these member functions, or we can overload them and provide our own versions of these member functions. Now these member functions are constructors and destructors. Constructors are member functions that will be used to construct a new instance on an object of our class. Destructor is a member function that will be used to destroy our objects. Now there are three types of constructors in C++. The first and the easiest one is the default constructor. The syntax for default constructor is as follows. First we write the name of the class followed by parenthesis. Now the parenthesis doesn't have any parameters, so a default constructor will have no parameters passed. And within the body of this default constructor, usually the body is empty. Here I'm just writing a cout statement that says that the default constructor was called. So now when we go to the main program and start creating new objects of our employee class, we will see when this default constructor will be called. So the syntax when a default constructor will be called is as follows. When we write employee followed by a variable name in the main function, we will use default constructor to construct this object. So employee now is the data type, E is the variable name, and since we are just following a semicolon after the variable name, a default constructor will be used to construct this object. Now the second way of constructing an object is by using a parameterized constructor. The parameterized constructor will allow us to pass some parameters that can be used to initialize our member variables. Now suppose I want to create a new employee whose name, position, location, and salary is known. I can use the parameterized constructor to let the constructor know that the name of the employee, position, location, and salary of the employee. And these parameters can then be used to initialize our member variables. So for example, in line 27, we are declaring the parameterized constructor. All constructors will begin with the name of the class. Name of the class here is employee. Within parentheses, I'm passing 4 parameters. All of them are const references. And I'm using syntax called as member initialization to initialize the member variables. Now the syntax is pretty simple. Once the attributes or parameters are declared, you can write a colon followed by names of the member variables that we want to initialize, and within parentheses the parameter that will be used to initialize the member variable. Now we can use comma to separate initialization of different member variables. So since I have 4 attributes that are declared within this class, I will initialize each of those 4 attributes by separating it with a comma. Now it's important to follow the same order in which these data members were declared. Notice name was the first data member that was declared in this class, then position, location, and pay rate. And when we initialize these member variables, we will initialize them in the same order. If we don't initialize them in the same order, we will just get a compiler warning. It's not an error, but we will get a compiler warning. Now again, within this body of the parameterized constructor, I'm printing that the parameterized constructor was called, so that from the main we will know when this constructor is called. Now the last way of constructing an object of our class is by using a copy constructor. Now a copy constructor has a special constraint. A copy constructor needs an object or an instance of our class to be already existing in memory, and we will use this existing object to initialize the newly created object. So there are multiple things happening. First, we will create a new object, and then we will use an existing object of the same type of our class to initialize our new object. So the syntax is as follows. First, we will write employee, which is the name of our class. Since this is the constructor, it always begins with the name of the class. And within parentheses, I provide only one argument. The parameter now is also of type employee. Now notice I'm passing it as a reference, const reference. Const is because this is a read only. We will read only its attributes to initialize the new member variable, new instance of our class. And it's a reference because we only want it to be an alias for an existing instance or an object of our class. We don't want to create a new temporary copy. Now the syntax that will call a copy constructor is as follows. So here I'm declaring a variable called E1. It's of type employee, and I'm initializing it with the variable E, which is already created. Now E is also of type employee, and E1 is the new variable or new employee that is being created. Now the other reference here is an alias to this variable E. So E is already existing in memory, other is just an alias. We will use other to initialize our newly constructed object E1. Now again, we can use the parameter list or the member initialization syntax to initialize our member variables. Now all I'm doing is I'm using the attributes of this other employee to initialize my new employee. Now to access member variables or member functions from an object or an instance of a class, we can use the dot operator. So object dot name or object dot function is the syntax to use the access the name or the member function from an object. So here I want to initialize name of my new employee using the name of the other employee. So the syntax is other.name. Similar to parameterized constructor, you can write name is equal to other.name within the body of this copy constructor. But the preferred way of doing it in C++ is by using the member initialization list. Now within the body of this constructor, I'm printing that the copy constructor is called. This will be important. We will see what are the instances when copy constructor will be called from the main function. Sometimes it can be surprising. We will not be expecting a copy constructor to be called. So by adding this print statement, since this is our first example of a class in C++, we will see when the copy constructor will be called from the main. Now the last default member function that is provided to you by the compiler is a copy assignment operator. The copy assignment method is needed to write statements like E1 is equal to E. Now both E1 and E are objects that are already constructed, so they're already in memory. Now all I want to do is copy the contents of E into the object E1. Now to do this, we need to say how to copy to employee objects. Notice with inbuilt data types, we don't need to provide how to do this. So for example, I have two doubles and I want to write A is equal to B where both are doubles. I don't need to tell the compiler what the equal to operator should do. But with inbuilt or user defined objects, we need to tell the compiler how to copy these objects. Now a compiler will provide a default version as I mentioned before, so we don't need to actually write this. But suppose we have some fancy things that we're doing with our class and we want to override it. This is the syntax. Now to overload an operator, the syntax is as follows. First, the name of the function has a fixed part, so it always begins with an operator. And then we provide the operator that we were trying to overload. Here I'm trying to overload the assignment operator, so the name of the function is operator equal to. Now within parentheses, we can provide a parameter. The parameter usually is the operand for this operator. So the operand for the operator equal to here are E and E1. So since we are working with classes, we can implicitly use something called as a this pointer to point to one of our operands. So this pointer is a special keyword that is reserved in C++ that is used to point to an instance or an object of a class. So for example, here, when we write statement like E1 is equal to E, this pointer will be pointing to the object E1. So since it's a pointer, it stores a memory location, and here in this case, it will store the memory location in which this object E1 is saved in memory. Now the other operand in this statement is E, and we can pass this second operand using the parameter to our function. So here I'm taking a const reference to an employee. So other is just an alias to this member variable E. So let me write this. Other is alias to E, and this will point to E1. So usually this pointer will point to whatever is on the left hand operand, and the right hand operand is the parameter that is passed to the overloaded function. Now the return type is again a reference to an employee. So we want to use this other, which is alias to E, to initialize E1, and then we will return back E1. Now within this copy assignment, I'm printing that the copy assignment is called, and then first we will check whether we are doing self-assignment or not. So suppose I write a statement which is E1 equal to E1. I don't want to do any work in this copy assignment method. So I don't want to rewrite the same object using the same object. To avoid that, we can use this if condition, which first checks whether this and other are different. Only if there are two different objects, we will initialize our member variables using the other object. So again, the syntax is the same. I will use other.name to access the name of the other employee, and initialize our employee or reset our employee using the name of the other employee. At the end of this function, we will return the object back. So this is the pointer. We will use the dereference operator to get the object from this pointer and return it back to the caller. So this concludes the copy constructor and copy assignment. Again, they are provided by default by the compiler, so you don't have to create them in your own classes. But it's good to know how to write these yourself. So suppose you need to overload them, then you can use the syntax that I've shown you to create your own versions. Now the last thing that the compiler provides us is the destructor. So destructor is a method that is used to destroy our objects. Now here the syntax is pretty simple. You have a tilde followed by the name of your class, and then you don't pass any arguments to this method. Now within the body of the destructor, usually you will write code that will be used to destroy some memory that you've allocated within your class. Since I'm using only inbuilt data types to describe the employee, which is string and integer, I don't need to destroy anything within my destructor. So here in my destructor, I'm only printing that the destructor was called, so that from the main we will know when objects are created and destroyed. Now let's move on. Let's see what are the other public functions that I've created in this program, in this class. So before we go ahead, I want to point out that it's important to declare these constructors and destructors as public. Now suppose, think about what happens when you create these member functions as private. What happens is that you cannot then create new objects from outside the class. You are only allowed to create objects from inside the class. There are situations where we will do this, but in most cases we want to provide the ability to create objects and destroy objects from outside the class, so it's important to make these member functions public. Now the other public member functions that will be part of any class are some getters and setters. So these methods will be used to get an access to our member variable. So if we want to read what is the current state of a member variable, we can use the get method. Or if we want to set a new state for our member variable, we can use the set method. So for example, first we will see how to declare and define a member function within the class. Then we will see how to declare the member function within the class and define it outside. So in line 84, I'm showing you how to declare a get method. So here the name of the function is get_name. All it will do is return the name of our employee. Now we can use this pointer to explicitly say that the name belongs to the object which is pointed to by this pointer, or we can just ignore the syntax this and write just return name. Both of them will return the same name. However, one of them is just making it explicit that we are using the object that is pointed to by this pointer to access the member variable name and returning it back. Now, since this member function is only reading our data members, it is not modifying any data members, we can additionally make this member function a constant. To do that, you can first declare the return type followed by a name, then within parentheses some parameters, and after that you can write const. So when you write const after the parameters, the compiler will make such functions as constant. Now constant member functions are only allowed to read and return the data members. They're not allowed to modify data members. Next, I'm creating another function called get_name. So get_name2, which is also returning name. The only difference is now it's not a constant function and it's returning a reference. So when we go to the main function, we will see what happens when we call the method get_name, what happens when we call get_name2, and why one of this is not recommended. Next, let's look at how to declare a member function within the class and define it outside the class. So the syntax is we are declaring a function called get_position in line 87. Its return type is string and it's a constant member function. Now to define this class outside, define this member function outside, the syntax is as follows. First you write the return type, then you provide the name for this member function, which is get_position. But before the name, you will have to provide a scope. Now the scope tells the compiler where this particular member function is declared. So since we have declared get_position within the employee class, the scope is employee. The colon operator is the scope operator, and employee is the name of the class in which this member function is declared. Again, we need to specify that this member function is constant since we declared it as a constant, and then body of the member function is just returning the position. So a good practice is to make your class declaration as simple as possible. So your class declaration should only have data members and declaration of member functions. The body of your member functions should be outside the class. Usually we put the definition within a header file, and then we will add the declaration definitions. We'll move the definitions to a CPP file. Similarly, we have a function to get the location, get the pay rate, and contrary to that, we have member functions that can now set member variables. So set member variables usually don't return anything, so the return type is void. Name here is set underscore name, so obviously it should set a new name. So the parameter passed is also a name. We will use the pass parameter to set the data member name. Now the question is, can we make these set functions constant? So let's try first and see what happens. So we should get a compilation error, and that's what happened. So the compilation error says that we are trying to modify in a data member of our class within a const member function, which is not allowed. So if you want to modify any member variables of your class, then you can't make such member functions constant. Okay, so this was a lengthy introduction to creating a new class in C++. Now let's move on to the main function and get back to our employee management system. So first, let's look at how to create employees with our new employee class. What are the different ways of creating employees? That is, how to use copy constructor, how to use copy assignment, how to use default and parameterized constructor to construct new objects, and when will these objects be destroyed. So first, in line 172, I'm using the syntax that will call the parameterized constructor to construct a new employee E. So employee is now the data type, E is the variable name, and within braces I'm providing the values that will be used to initialize our new employee. So the new employee's name is Rick. He will be a chief scientist working in space and has a salary which is $500,000. Now in line 180, we are creating a new employee, this time using a default constructor. Before we go to 180, first let's check what happens when we try to print the name of the employee using directly the variable data member name. Notice data member name is declared as private, so this should give us a compilation error. The compilation error says that employee name cannot be accessed because it's private, so we are not allowed to directly access this name. So the answer to this question is that we should get a compilation error. Now let's move on. So in line 180, we are calling a default constructor to construct a new object, and we are storing it in the same variable E. The question now is, what will be the name? So if I use now the method get underscore name to get the name of our employee, will it be Rick? Will it crash? Will it not compile? Will it be an empty string, or will it be random? So these are your choices. So now the answer should be it's going to be empty. So since we have a default constructor, notice we are not initializing any of our member variables. By default, a string in C++ will be initialized with an empty string. So the name of our new employee E will be empty. So let's verify this by running the program now. Okay, now since we are printing when a constructor is called, we will see a lot of print statements. So first, let's go through these print statements. Notice first, employee E was constructed using a parameterized constructor. So we have this parameterized constructor was called. Then we have this default constructor called to create this temporary object on the right hand side of line 180. And then a copy assignment operator is called to copy this temporary object into this variable E. Notice copy assignment is called here because E is already constructed and is in memory. So E was constructed in line 172. And finally, a destructor was called to destroy this temporary object on the right hand side. The temporary object is no longer required once we assign it to the variable E. So the destructor is called. Now the name of the employee is empty. Therefore, we are not seeing anything printed on the terminal. We just see an empty line. Next, let's look at employee E1. Employee E1 has a name, position, salary, and all those things. Now in line 191, we are again using copy assignment to copy this employee E1 to E. So let's first look at what was called. So when E1 was created, the parameterized constructor was called. Now when we are calling E is equal to E1, notice only the copy assignment operator was called. So we don't have this extra default constructor being called and destroyed, since we are only using object E1, which was created before. And we don't need to destroy this object because we need employee E1 also. We'll be using it further in our program. So only a copy assignment was created. Now E will be equal to E1. Now suppose I write the statement E1 dot set name Tina, wherein I'm changing the name of the employee E1 from Bob to Tina. And the question is, what will be the name of the employee E? Will now employee E also become Tina? Will the name of the employee E be Rick? Will it still be Bob, or will it be something random? That's the question. Now the answer is employee E should still be Bob. Since we are using E1 to initialize E, name of E will be Bob. In the next line, we are only modifying the name of the object E1, and therefore only the object E1 will now be Tina and not object E. Okay, so let's continue and check what is the name printed. And the name of E is Bob. That's good. Next, we're creating a new employee E2. Again, we are using the parameterized constructor, but now the syntax is slightly different. We're not using braces, but we are using parentheses to pass the parameters. Both of them will do the same thing. So let's go to the main and hit continue. Now notice a parameterized constructor was called when we created E2. And now I'm using this method get underscore name 2 to get the reference of the name back in the main program. So I'm creating a local variable called name. It's a reference to string, and I'm using get underscore name 2 method to get the name of this employee and store it within this alias name. Okay. Now since E2 has name Tina, this will also be Tina. And now since I have a reference, I can write to this variable name. It's not a constant, therefore it's not read only, so we can modify it. So now suppose I change the name to Bob. The question is, what will be now the name of E2? Will it still be Tina, or will it be Bob? Or will it be something else like Gina? Now the answer to this question is hidden within this call. Since we are returning a reference to our member variable, name is just an alias to the name of this employee E2. Now if we use the alias to modify the content of that variable, we will also modify the content of our object E2. So now the name of our employee E2 should be Bob. So previously it was Tina, now it should be Bob. Now this is okay, so we answered the question. But what's important here is to notice that the name of our member variable was supposed to be private. That is, we were not supposed to provide access to our member variable and let it be modified directly from outside the class. To modify a member variable, we were supposed to use a set member function to change it. But since we wrote this member function get underscore name 2, and then here I'm supposing that by mistake I returned a reference, this allowed whoever is calling this function to modify the object without the class knowing that we are trying to modify it. So here the class is thinking that we are only using this method to get the name of an employee, but since it's returning a reference, it is used to also modify the name of the employee. So in your programs, don't declare get functions by returning a reference, always return by value, so that you only use the name that is written back to you and read it and not overwrite it. Now the last thing that I want to show you here is how to use copy constructor. So we already saw the syntax when we looked at copy constructor. E2 is an object that is already constructed. E3 is a new object that we are trying to construct, and we will use E2 to initialize E3. So in this case, a copy constructor will be called. First, a new object E3 will be created, and E2 will be copied into E3. So let's continue, and then let's look at the print. Notice now we see that the copy constructor was called. That's good. Now let's look at another way of calling copy constructor. Now I've written a function called pass by value, and I'm passing our object which is of type employee to this function pass by value. Now let's go to the definition of this function. Since it's pass by value, I'm passing this parameter as a value. Now when I pass the parameter as a value, what happens is first E3 is an object of type employee that is already created. And we are now trying to create this temporary object EMP, which is going to be initialized with E3, which is already in memory. So this again should call a copy constructor. So let's put a breakpoint within this function and let's hit continue. Notice now again a copy constructor was called. This time the copy constructor was to initialize this local variable EMP, and within this function I'm just printing pass by value and the name of this copied employee. Since we're copying it from Bob, the name should still be Bob, so let's continue. Okay, now notice Bob is the name of the employee and we see pass by value being printed. Now at the end of this function call, this temporary object EMP should be destroyed. The role of the temporary object, scope of the temporary object was limited to this function. So once the function call ends, this temporary object is deleted. So when you pass by value, a copy constructor will be called at the beginning and a destructor will be called at the end. Now instead, if I pass it by reference, let's see what happens. Now let's remove this breakpoint and hit continue. Now notice no constructors or destructors were called so far, so that's good. We are only saying that EMP is an alias to the object that was passed to this function passed by reference. And now again I'm printing the name of the employee, so we're still passing E3, so name should be still Bob. Also at the end of the function call we didn't destroy any objects, so that's good. Now the only thing that one probably needs to modify here is to make sure that this is a const, so that we won't accidentally modify this reference that we are passing to this function. Suppose we want to modify the employee that we are passing, then we can remove the const. Okay, now let's go ahead. Okay, now finally this is a new syntax that shows you how to construct an object. Here again a copy constructor will be called. So the syntax is employee, which is the data type, E4 is the new employee that we want to create, and we are using E3 to initialize E4. So you can use this function call operator and pass E3 as the parameter. And this time again we are using an already constructed object E3 to initialize a new object E4 that is going to be constructed. So this will call the copy constructor. So let's continue and check what will be the print. And notice again the copy constructor was called. Now finally, I want to show you how to use stdcout and print user defined data types. Now previously we were using cout to print inbuilt data types. So there was this operator which was overloaded by C++ for us to support printing of inbuilt data types. Now with user defined data types, C++ will not print our employee directly. We need to overload this operator and then let C++ know how to print our employee objects. So suppose I write syntax like in line 218, which will use cout to print a newly constructed employee. How should we overload this less than operator? So first let's see the definition of this overloaded function. Notice again this is an operator, so the syntax for this has a specific name. So operator is fixed followed by whatever is the operator we are overloading. So since less than is the operator we are overloading, the name of the function is operator less than. And now we have two parameters that we are passing to this operator. The two parameters are the two operands that are the two operands for this operator less than. Now since we are declaring this function outside the class, we need to provide both the operands as parameter to this function. Suppose this was declared within the class, one of the operands is pointed to by this pointer, so you don't need to pass it. The second one is the right hand operand that needs to be passed as a parameter. Since this is declared as a global function outside the class, we need to pass both the operands as parameters to this function. Now the left hand operand is of type oStream. So cout is of type oStream. I'm passing it as a reference. Name of the variable now is OS. So OS is just an alias to cout. And the second operand is of type employee. So the second operand emp, which is again a const reference, is an alias to this employee object that we were passing and printing. Okay, so far I hope this is clear. Now the return type again is an oStream reference. Now why the return type is oStream reference is because, so first we are looking at this part of this expression where cout less than employee is printed. Now once we are done with this function call, notice we are chaining this operator less than to print additional things. So now the return value of this first less than should return again an oStream ampersand, so that the left hand operand for the second less than operator is still of same type, which is oStream reference. So the return type from this function is oStream reference. Now within the function, we can use the get methods from our class to get the name, position, pay rate, and location of our employee. Now these methods get name, get position all return a default data type, which is either a string or an integer. So we can use less than directly to print them, like how we were doing before. Now instead of cout, we will use OS to print these. And since OS, we pass cout to OS is just an alias to cout. So at the end of this print statement, we can return back OS, and this will help us to print our employee onto the terminal. So let's continue and check what will be the print. Now notice parameterized constructor was first called. This was called to construct this local object here, and then we use the overloaded operator to print the employee onto the terminal. So this is great. So whenever you create your own classes, and if you want to print an instance of your class onto the terminal, you need to overload the less than operator, and then let the C++ know how you want to print an instance of your class. Now notice again a destructor was called at the end of this call. The reason why the destructor was called was because this variable, this was a temporary employee that we were creating, which was only used to print. Once we print the employee's information, the employee can be destroyed. Now suppose you don't overload the less than operator, then you will get a compilation error. Okay, so now finally we can go to our employee management system again. So let's now start designing our employee management system, this time by using our employee class. So now I can create a vector of employees. So in each, so in my vector, each element is now of type employee. And since our employee class encapsulates all the information of an employee, which is the employee's name, position, pay rate, and the employee's salary, we only need one single vector to store the information of our employee. So we have only one variable employees, which holds all the employees that are part of our organization. And now I'm using braces to initialize the employees of our organization. There are 5 employees to begin with. Their name, position, space, location, and salary is provided. So here I'm using parameterized constructor to construct these temporary employees, and I'm pushing them to the vector, or I'm constructing a new vector which will have these employees initialized. So let's look at the print. Now notice a lot of things happened. So there were 5 parameterized constructor calls, then there were 5 copy constructor calls, and again 5 destructor calls. The 5 parameterized constructor call should be evident. So that's because we are creating these 5 temporary objects using parameterized constructor. The 5 destructors should also be clear. The 5 destructors are because we are creating these temporary objects only to initialize our vector. So once the initialization is completed, we need to destroy these temporary objects, so the destructor will be called. Now, to fill our vector with these temporary employees that we have created, a copy constructor will be used. So since the temporary employee is already created, and now within our vector, we want to create a new employee and copy the information of the temporary employee. To do this, the copy constructor was called. So notice again 5 copy constructors were called. Now we can use the method print underscore employees to print our employees onto the terminal. So previously, with our previous design, we used to pass 4 different vectors to print underscore employee function. Now notice we are only passing one vector, and this already simplifies. We won't have problems like passing the name instead of position and juggling with orders, and such bugs will already be eliminated with this approach. Now within this function print underscore employee, I'm using the range based for loop iteration. So we looked at this in the previous class, wherein you can access each employee that is part of this employee vectors and then print it onto the terminal. So since I've already overloaded the less than operator, I can directly print an employee with just this small syntax. So this is much more cleaner way of printing an employee. We're just passing one single vector. We've overloaded the less than operator. Now we can directly print our employee with this small piece of code. Again, notice I'm passing the employees as a constant reference, so we will not be allocating and deallocating memory from this function call. This is only an alias to the vector that was passed. Okay, so once we print all the employees, we will see what happens. Let's go back first. Notice no additional constructor or destructor was called. All we are doing is looping through each employee and printing the employee's information. Okay, now let's look at how to hire a new employee. To hire a new employee, we had this method called add underscore employee. Now previously we were passing 8 parameters to this function. Now we are only passing 2 parameters. The first parameter is a temporary object that will describe the new employee. Second parameter is our vector, which holds all the employees in our organization. Now again, the definition of this function will be very simple. It's only one single line. We are using push underscore back method to push this new employee into the employees vector. Notice again we are passing our temporary employee as const reference, so no copy constructor. The second one is passed as a reference because we are modifying it by using this pushback method. And since we are using pushback, we will call copy constructor to copy this temporary object that is passed to create new object within our vector. So when we go ahead and continue our program, we should see that a new copy constructor will be called to add our new employee. So first let's look at the size of our employee. Notice the size is equal to 5 right now. So first let's continue and add one single employee. Now notice a lot of things happened. So all we were doing is creating a temporary employee, adding it to our vector, and then returning back from the function. So you would expect a parameterized constructor to be called, and then a destructor to destroy this parameterized temporary object that was created. And then one single copy constructor to copy this temporary object into our vector. However, there were 6 copy constructor calls and then 6 destructor calls that happened. Now the reason why those 6 copy constructor calls happened is because our vector initially had size which was equal to 5. Now to create a new position, C++ needs to first resize our vector, that is, it needs to allocate enough memory to hold the 6th element, and then once the memory is resized, C++ will copy all the previous elements back into the new allocated memory and then add the 6th element at the end. So this caused this additional 5 copy constructors to copy the previous elements after resize. and then the last element was added. So this additional copy constructor and destructor can be hidden. Since we don't know what happens, we are not even overloading this copy constructor method in our programs. There could be a lot of additional overhead that can happen due to this additional copy and destruction. So it's important to pay attention to these small things, as in when your program becomes big or you're working on a bigger project, these minor points can lead to major issues. So for example, let's think about this for a second. Let's think that we are creating this employee management system for Amazon. Amazon has 1 million employees. Now, with 5 employees, we saw that 5 different copy constructor calls were called. Now, for each new employee you add, this will become a summation, and so as n increases, the number of copy constructor and destructor calls will be almost polynomial in square. So if you have 1 million employees, then you will have 1 trillion copy constructor and destructor calls that will be made to add new employees. So this can be catastrophic. Something as simple as this, if is not thought about when we are writing classes, can lead to performance issues that can be very bad. So it's very important to think as a programmer when we are coding, what are the things that can be internally called by C++ and how we can optimize it to reduce these additional overheads. So now let's go ahead and let's add a new employee. Now this time let's check what happens. Now notice only 1 parameters constructor call was made, 1 copy constructor call was made, and 1 destructor call was made. Now the reason why this happened is the previous time the vector was resized, C++ was a little smart. It resized it to hold more than 1 element. So it was expecting us to push another employee soon, so it allocated memory sufficient for 2 employees. So therefore we only have 1 copy constructor call. But now let's try to add the 3rd employee, and notice we are back to the same problem as before. All the previous employee needs to be, first the vector needs to be resized, so you need to have sufficient memory to hold all the new employees. All the previous employees needs to be copied to their new locations using copy constructor and then destroyed. And finally, the last element that we are pushing will also be copied and destroyed. So this problem is persistent. So if you keep adding employees one at a time, then you will have this polynomial number of copy constructor and destructor calls that can be time consuming. Now, first let's print the new employee to just verify that we added Dave properly to our employee management system. Okay, so notice now Dave, Ryan is the last employee that was added. So we have Dave, Brad, and Ryan. That's the last 3 employees that are printed in the employee list, the employee vector. Now a better way to do this is, there are a few different ways we can avoid this additional copy constructor destructor calls. I'm showing you the simplest way here. The simplest way is to first declare a vector called employees. It again holds an employee class object. But first I'm reserving memory that says that I have at least 100 employees that I expect to be part of my organization. So here in the beginning, I'm allocating memory that is sufficient for 100 employees, and our vector now can store at least 100 employees before it needs to do the copy constructor destructor cycle to make more space for new employees and then copy back the old employees. Now with this, what happens we will see. Let's just go ahead and run this. Okay, so notice now I'm using a new method called emplace_back. Emplace_back is similar to pushback. The only difference is you can use in-place construction of objects. With pushback, we were creating a temporary object and then copying the temporary object using a copy constructor, then deleting the object. So there were 3 calls made. Now instead, if you use employees underscore back, you will only construct this object directly inside the vector by calling a parameterized constructor. So now we have simplified from our previous code. We are only having 5 parameterized constructor calls to add our first 5 employees into our employee management system. So there is already a good reduction. Now again, let's print our new employees just to verify that everything is going fine. Notice again, we can print our employees back. Now let's see what happens when we do add employee. Again, I'm creating a temporary employee. So a parameterized constructor destructor was called. And at the end, only one copy constructor call was made. Now, since our employee vector has enough memory to hold 100 employees, we don't have that vicious cycle of resizing our vector, copying the old elements back, and then adding a new element. So this is one way you can reduce the number of calls to constructor and destructor. This is still not optimal because a priori we are allocating a lot of memory. Maybe our organization has only 10 employees and we don't need this additional memory that holds space that can add up to 100 employees. So this is the downside of this approach. There are other approaches which are a little more complicated, so let's not go into it. Now let's just finish this employee management system by looking at what is this find underscore employee method. So suppose we want to search an employee by name, how to do this with our class. Notice now all I have to do is declare a temporary employee in the main function and pass this temporary employee into our method find underscore employee. Suppose our method find underscore employee finds the employee within the vector of employees. We can fill the found employees information into this temporary object that we are passing, and then use the get methods to print it on the main program. So again, the return type is the same. If find underscore employee finds this employee that we are searching for in the vector of employees, it will return true. Otherwise, it will return a false. Now again, the body of this find employee method should be very simple. All we are doing is using the range space for loop to iterate through all the employees. We will use get underscore name method to get the name of an employee and check whether it is equal to the name that we are looking for. If it's equal to the name that we are searching, we will use copy assignment to copy the correct employee information into the variable that we have passed from the main program, and we will return true. So now let's execute this. And let's see whether we can find Rick in our vector of employees. Okay, so notice again, Rick was found, and all that happened here was, let's see, there were a few, yeah, so all these destructor calls happened only because I allocated memory for this temporary variable employees within this particular scope. So since I created this new scope and then created variables within the scope, once we exited from the scope, all of them were deleted. So find employee call did not create any new memory. All it did was loop through the employee vector and searched for our the employee that we were looking for. The only thing that our find employee method did was use copy assignment to copy the found employee. Finally, let's just look at Jim-Bob. We know that Jim-Bob is not part of our vector of employees, so we should not find him. So our find underscore employee method should return a false, and we see that employee Jim-Bob is not found. So this completes again this program on the employee management system using classes. Now we saw that with classes, we overcame some of the challenges that we discussed at the end of the previous design, wherein we had issues like there were multiple vectors, one for each attribute that described the employee. You could have issues like not all vectors will be of same size. The program still compiles, but then at runtime you will face runtime crashes. You can mix up different vectors which are of the same type while you're passing a function, and you will probably not notice this for a very long time, and such issues can be really hard to find when your program becomes longer and longer. All these issues were solved by creating an employee class wherein we encapsulated all the information related to an employee within this employee class. The methods print underscore employee, find underscore employee, add underscore employee also were simplified. We only need to pass one vector of employees now instead of passing one vector per attribute. And we also saw how to use operator overloading with classes to simplify the print statements. So we can directly print an instance of our class by overloading the less than operator to print information about an employee. So using classes makes your life simpler. The code is more organized. So I can just look at the declaration of a class to see what are the attributes that describe an employee. I can look at the methods or the member functions of the class to see what are the member functions that can be used to access these data members. And with classes, you also need to pay attention to how memory is being allocated and destroyed. So if you don't pay attention to the constructor and destructor calls, it can lead to issues that will be really, really difficult to debug and find out. So suppose we already saw one such problems that if we are using vectors to store user-defined objects and we don't pre-allocate enough memory for our vector, C++ internally will keep resizing the vector, keep calling copy constructor and destructor, which can make your program really slow. So there are some downfalls also by using classes. The downfalls are smaller than the advantages that we get by using classes. So it's recommended to use classes, but you should be careful and you should know what internally C++ is doing to use it properly. So I hope this class was useful for you to get an introduction to classes in C++. Next, we will see if time permits, we will go through some advanced concepts like polymorphism and templates that will make the use of classes even more useful when we are writing more advanced programs in C++. Thank you.